You've likely identified molecules as identical or constitutional isomers before, and you may have done stereoisomers with cis and trans, but here we're going to do some more of that. So I've got a couple of structures here, and I'm going to use a couple of tools to decide if they're the same or constitutional isomers or stereoisomers. One of the things I'm going to do is I'm going to number things. Even if I number it wrong, I'm going to try to number it consistently. So I'm going to number the longest chain. I'm up to 4, and if I go up, I go 5 and 6. And this one I go 1, 2, 3, 4, 5, and 6. Second thing I'm going to do is look at functional groups. Here's a methyl group. Here's a methyl group. This one's at 3, this one's at 4. Here I've got a methyl group at 3, and here I've got a methyl group at 4. So these are identical. This next one, I'm going to convert things to line angle or skeletal structures. So I've got my double bond and 2 methyl groups there. Here I've got a double bond, a methyl group down to the left, methyl group up to the right. So these two both have 4 carbons and 2 double bonds. They are constitutional isomers. I'm going to add another structure. I'm not going to write it all out. I'm just going to do the line angle structure for it. But here I've got a double bond and 2 methyl groups on the end, but it's not the same as this. Down here I've got the trans isomer, and up here the cis isomer. So these would be stereo isomers of each other, while as the cis isomer would still be a constitutional isomer of this 2-methyl-1-propene. Let's go down to these molecules. It can be hard to see in these condensed formulas, so I'm going to go to the line angle structure. Double bond, that gets me to this carbon. Next carbon, bonded to 2 methyl groups. Let's come over to this one. Methyl to this CH, that CH down to here. We'll go right to this C, and then double bond. I'll draw it at a bit of an angle over to this CH2. Okay, these don't look exactly the same, but they both have double bond starting at 1. They have an alkene starting at 1. Then I go 2, 3, and at 3, this has a methyl group. 1, 2, 3 methyl before they finish off as butene. So these molecules are identical. Let's look at a couple other examples of isomers. Here I've drawn an ether, a cyclic ether. It's got 1, 2, 3, 4, 5 carbons. And here I've got an epoxide with 1, 2, 3, 4, 5 carbons. So these are constitutional isomers. I want to look at one more kind of stereoisomer. We've seen cis-trans stereoisomers. Here is a stereoisomer you can have with rings. So I've drawn epoxide rings. But off of each atom, let's redraw these in an expanded form. There's the epoxide ring. Each of these atoms, each of these carbon atoms, have a methyl group and a hydrogen. So, a hydrogen and a CH3. And one of those is going to have to come out of the paper towards you, and the other back in, because you know this has to have bond angles close to 109.5, because these electrons and these electrons and these electrons and these electrons are all repelling each other. Now it's not going to be exactly that, because this ring is extra sharp with 60-degree angles. So we've got one coming towards us, and on this side we could have the same with a methyl group coming out towards us, making the hydrogen go back away behind the paper. But these could have been switched. So here I've drawn the methyl group going back behind the paper on one side and out of the paper on the other. And so these, all the atoms are connected the same way, but going different directions. We can recognize these as stereoisomers. Now, in a more advanced class, you might learn how to classify the different kinds of stereoisomers. But for recognizing stereoisomers in biochemistry and just learning that they are important and that that's something you need to pay attention to, this level of understanding is enough.